Well, good morning, everyone, and thank you for joining us. I have 10 o'clock on the dot, so we're going to go ahead and get started today. Today's webinar is part of our Certified Livestock Manager webinar series. We're going to be talking about some manure technology, specifically within the sensing realm. So with that, if you guys do need CLM credits or you like this webinar and want to stick around with this, we will have some more throughout the year. Our next one after this one will be June 1st, and then the one after that will be August 3rd. So feel free to, if you haven't already registered for the whole series, that link is there, that go.osu.edu/CLM26, and you can sign up for the rest of that webinar series, those ones in particular, or the whole year. And topics will be decided at a later date for each of those. So today's webinar is brought to you by the OSU Extension Water Quality Team. You can see all of our team members and the regions that we cover highlighted in different colors. We will start at the top, covering Williams, Fulton, Lucas counties is Heather Torlina. Rachel Henry covers Paulding, Defiance, and Van Wert there in the orange. Myself, I cover Auglaize, Allen, and Mercer counties. I'm down in the purple there. And then Amber Emmons covers Henry, Wood, and Ottawa counties, and she is in the bluish green color. We do have 2 vacant positions at this time. So once we get those filled, hopefully we'll have some more team members for you guys. And as always, if you guys have any questions about what we do, how to contact us, or anything like that, our website is listed there, waterqualityextension.osu.edu. Feel free to check that out to see more of what we do. So today's webinar, our wonderful speaker today is Dr. John Fulton. He is in the Department of Food, Agricultural, and Biological Engineering here at Ohio State University. And he is going to talk to us about some of the NIR sensors. So I'm going to stop my share, and whenever you're ready, we can go ahead and get started.
That up and look good?
Jocelyn? That looks good. Yep.
Oh, great.
Thank
All
you.
Right. Well, thanks, Jocelyn, and thanks to the team for the invitation to be here today. We're going to just talk through where things stand with the NIR, or near infrared technology, that is being at least offered to for liquid manure application. Okay, and I'll get through some of that here in a little bit. So to start off with, though, just a little bit of reference on technology. So just to kind of see where we've been in the last almost 16 years, but Marv Bad did a farmer survey in 2010. And in that survey at the time, really, they were thinking about precision ag, and as it relates to commercial fertilizers. At that time in 2010, 19% of the farmers said they were doing some kind of variable rate application of potassium, phosphorus, and lime. About 23% of the farmers are actually doing some kind of precision sampling, which we normally refer to as like a grid sampling or management zone type sampling strategy. So those are where we were in 2010. As we looked also, a lot of the farmers at that time, a good percentage of them, thought that the benefits of precision ag or technology exceeded the cost of using it, okay? And so they were starting to consider about adopting it at that time. But they felt at that time, at least, the variable rate application of fertilizer, again, this is mainly commercial fertilizers, was most profitable. We advance here to more recent, and we just got some additional data in from Northwest Ohio. And a lot of times this data can move a little bit, plus or minus 10% on some of this, but in general, you get kind of the understanding of where we're at. One thing I wanted to state today, and this continues on, we're somewhere around typically 50-50 on own versus lease ground. And when we talk about technology or moving the needle on practices, that comes into play because of the large the level of leased land out there for farmers. Now, in those surveys, I will say uh, that a majority of that land has a 3-year plus lease on it. And so there is opportunities for farmers to look at maybe doing improvements because they've got more long-term uh, commitments on those leases. Of those in those surveys, we're around 75% today using grid or zone sampling. Majority of farmers still or rely on retailers or custom applicators that are out there for the VRT capabilities. So majority of the time, the capabilities to do variable rate is not on farm. It's off farm, primarily through retailers or some of the custom kind of third-party custom applicators here in Ohio. 62% are using VRT or variable rate application of phosphorus. And so again, as we look just over, in this case, 14, but we're thinking about even the 2026 numbers that I was just looking at, we've come quite a long ways from 20% adoption on variable rate phosphorus, 23 on precision sampling to 75% on precision sampling and just over 60% doing variable rate. And so we've kind of matured. There's plenty of opportunity out there to better match our P and K and even pH out there. So that kind of brings us into talking about, well, why, John, are we constant, or why are questions arising around NIR sensors? And this is one of the reasons why. This is work again we did with Glenn Arnold a few years back, but as pits were pumped, in this case, we had 4 pits that were pumped. We were collecting samples every 20 minutes coming out of those pits. But you can see this was the PO2 concentration. And in 3 of those pits, it was fairly low. But as you get down here, primarily to the bottom of that pit, all of a sudden you see, a huge jump in the PO2 concentration there. This pit was a little bit different. We started high, okay, and then have gradually leveled out at a lower concentration. The challenge there is that if this does exist, okay, if we have variability as we pump these pits in terms of even total nitrogen, P or even K, but we're going to be most interested in a total P, total N in a sense. There is no feedback, right? We typically will take a sample from a field, we take a sample from the pit, we match that up through our nutrient management plan, and we say, hey, we can put X amount of gallons per acre out on the field, though in some cases we may see this variability, in particular these 3, where we're pumping and all of a sudden we see this drastic change or increase in phosphorus concentration. And so that it lends itself to the opportunity that on-the-go liquid manure sensing could provide to Ohio farmers. Okay, and again, this sensor, all these sensors are based on NIR or near infrared technology. It's pretty much very similar amongst the companies. I'll get into why some of the differences exist, but the technology itself is using near infrared technology. And so why use near infrared, these sensors potentially here in Ohio? Number one, there is an opportunity, I'll say is an opportunity to apply nutrients more accurately, okay? And that's really leads to reducing over application of nitrogen and phosphorus out on fields when we're applying manures. There is that opportunity. Obviously, there's opportunities to save on fertilizer costs. We know that the research that Glenn's been doing in terms of trying to use manure as a fertility or nutrient component in our fertility budgets. Okay, so there's an opportunity with manure to save on fertilizer costs, mainly because of this over application noted in number 1. And then this third thing is real time if we do have variability, we have the opportunity knowing that during the application and can adapt and make adjustments accordingly if we see an increase or decrease out in the field. Okay. Obviously, as we get through, and I'll show a little bit of the record keeping, but we actually have digital records, and that not only has for record keeping, but also potentially for some environmental compliance it could be used for. And ultimately, the idea here is better match our N and P concentration coming out of the manure pits to what we can place out on the field. And if variability exists, ultimately we're going to have a reduction in the impact that we can have environmentally. So where can NIR sensors be used? Today, really we're talking about tankers, primarily the people that I talk to or work with in Canada. That's where we see the use at, is on tankers. Here in Ohio, we're basically probably going to use it on a drag line. And so the sensor's actually mounted in line here out on the applicator, okay, to monitor the constituents. I do want to note that it could be and can be actually installed at the pumping, okay, even though I know sometimes it could be a mile plus two, or, quite a bit of pumping distance, but you can, and I can actually put it on a manure pump, okay, and monitor right at the pit. But most frequently, you see people, because of the application, using it on tankers or drag lines today, okay. What's out there? The reality is today in Ohio, there's only one real system that's available, and that's the John Deere Harvest Lab 3000. I'll talk a lot more about that here shortly. There are others out there, mainly available in Europe today. Okay, uh, this is a new one that I just came across here late last year, but Samson NIR Scan is talking about releasing that here in North America, potentially this year still. So there could be some more options coming forward. There are a couple other companies, again, in Europe that provide more of a benchtop type analyzer, so it could be used at the farm. I just want to bring that kind of forward here, that some of these don't have to be in line. They could be just at the farm. The Harvest Lab 3000 can not only can be used in that capacity, and not only could be used on the drag line or tanker, but you can bring it in, set it on a bench top. It's got basically an eye at the top. You can put a sample in and can read that sample. So it can be used as a static sensor as well. So, but today, if you're going to ask me, or if a farmer wants to use NIR technology, you're basically going to have the John Deere Harvest Labs 3000 as the only available option. Potentially, we'll see some other ones come into play here in the near future. So here's the John Deere Harvest Lab on the left. That was actually mounted on a drag line or out, but it was basically mounted upside down. Though you can't see it, this linear pipe was welded on where we can mount it. And then the eye of that sensor is actually looking inside that pipe. So the idea here, at least on this one, is we assume that pipe's always fully full, but in case you get foam or a little bit of an air pocket at the top, in some cases happening, you don't want that. That can influence the reading. So we mounted it on the bottom to make sure there's always something, liquid was always in contact with the eye. Okay. So as mentioned, the John Deere Harvest Lab has been fully commercialized. It's not only being used here in North America, but it's being used in Europe for manure applications. And as I mentioned, there's some other companies that primarily are focused in Europe that you'll see kind of similar technology or bench type technology available to farmers. In Europe, there are a lot more regulations are a lot more strict. And so not only having records but having no understanding what actually got applied is much more important in Europe. And so that's why you've seen these NIR sensors over the last about 6 to 8 years being used more readily on farm over in Europe, is because of the compliance and monitoring applications over there. What do they measure? Okay. I'll talk about this in the next slide. We'll get to the John Deere 3000, but really what we get down is NPK, ammonia, and dry matter are the basic constituents that it's going to actually measure regardless of the company. Okay. So NPK, ammonia, and dry matter are pretty basic 5. There's some that extend that and do some other constituents, but all of them that I've been around will provide these 5 constituents to the user. Okay. So here's where for the Harvest Lab 3000, a couple things to know about it. Obviously, it does dry matter, ammonia, nitrogen, phosphorus, and K. Um, those can all be recorded in the cab. Plus, and I'll show you some screenshots, the operator, in this case of the tractor, can actually see that in real time, and then if changes are occurring or not, so they can actually see it right on screen. Okay, but those in terms of John Deere are the 5 constituents that they are measuring today and provide not only electronic documentation in terms of recording, but actually give you this information back to the operator in the cab of the tractor as it's applying the manure. Some of the ideas, just a summary of the Harvest Lab 3000. It does take about 4,000 plus scans a second. Okay. I want to emphasize folks that may have been around this, but in terms of mounting that, you want to mount that sensor either on the bottom or we'll call it at the 4 or 5 o'clock, slightly rotated. Again, it's key to keep the liquid manure in contact with the eye that's doing the measurement. Okay, and that's pretty important. You don't want to. It's not recommended to put this on top of the pipe in line. Okay, so you want to keep that towards the bottom to keep that eye fully covered with the manure, the liquid manure. Okay, there is opportunity with the John Deere technology as you get kind of acclimated to it. It can adjust the tractor speed. Okay, so if it sees that maybe you got to pick either N or P to manage, but you can put a threshold on and say, I don't want to go over this. Okay, and it'll try and match the tractor speed to maintain whatever threshold level that you put into. We haven't used that too much. We've kind of tested that preliminarily. It can work. Obviously, you're limited on what the maximum tractor speed would be based on horsepower and the size of the tractor and what you're pulling. But there is the opportunity to step in and it can adjust the speed. Data from this flows into the John Deere Operations Center, so you can grab your summary data as far as reports and also actually look at maps of the applied, NPK, ammonia, and dry matter if you want to as well. And I'll show you some of that here in a minute. I will say in Europe, specifically in Germany, the sensor is actually certified for accuracy. We'll talk about that at the end of this in terms of where we're at here in Ohio and surrounding states. But in Europe, they spend a lot of time calibrating and have actually had this certified in Europe. As mentioned, the sensors recommended from John Deere to work on tankers or dragline systems. Okay. And I will mention this, though it's not part of the manure application, but the Harvest Lab 3000 is going to be used for on some of the new S and X John Deere combines as well. They'll come fairly standard on those combines. They're going to be measuring protein, starch, and fiber, and some other things, whether it's forage or in grain. They can measure constituents of those as well. So you're going to see it being more used primarily on farms here in the U.S. on combines coming up in the near future. So as far as this technology, obviously you got to kind of be a John Deere person. Okay, it makes it pretty fairly simple to get it installed and working with. And you got to be using one of the newer displays. This does not work with the older displays. Okay, and so I think it's the 4 and 5 displays are newer that needs to be used in order for it to collect the data and for you can see the information on the screen. Just some estimates that gets out, well, how much does this cost? It's not cheap. Obviously, there is a significant cost. If you have the sensor itself and getting it mounted, because you end up having to have a mounting bracket built in order to mount it on. Part of that bracket usually comes with the purchase, but you're in somewhere between 30 to 45,000. That includes the sensor, the wiring harness, and the bracket that you would have to build or have someone build for you in order to put it in line to an application system. Okay. Now, it also requires a flow meter. most guys or most systems already have a flow meter, so that cost isn't needed. This system pretty well integrates in and can read the existing flow meters that are pretty standard on manure application technology today. But again, if you don't have the flow meter, there's an additional cost to that. And then you could get into some calibration and some software upgrades, though it's uncertain how all this will cost in the future, but there could be some annual cost to you, 800 to 1500, roughly speaking, that you could get involved with as well. But up front, the sensor and all the mounting, the wiring harness to make it work with the John Deere tractor, you're going to be in somewhere between $30,000 and $45,000. So what do we get out? There on the left side is actually a picture taken from a screen. If you've been inside like an 8R, it's a pretty standard screen. You can see our guidance lines are already in there and using. But you do get as applied data out, or what we call as applied data. So in the bottom right is just a quick, and I'll show some more here in a minute, but I can get as applied data for liquid manure application out of John Deere operations, just like I've gotten, as applied data from planters, nitrogen applicators, sprayers, etc., in John Deere operation center as well. And so that information is flowing and can be either viewed and or downloaded from John Deere operations center. This is what the display would look like. So if you're sitting in the tractor, this is what the actual operator would see. This is the flow meter. Okay, this is 1,632 gallons a minute. Down here, you can set your target rate, like I said, what you're wanting to meet out there, or you can actually set your limiting factor as gallons per minute. Either way, and so you can set those numbers down here. As you're applying, it gives you phosphorus, ammonia, dry matter, and potassium out values down here at the bottom. So you can actually see those changing in real time if they are changing at all. Obviously, it gives you over here the coverage map, that's collected. That's the blue here as we kind of paint the field up. It gives us this. And then in the top center here, if you have it available, if you have the speed control enabled, you'll see that in the top center of the screen as well. But the main thing I wanted to show is you get your flow, okay, gallons a minute out, and down here towards the bottom you get the constituents monitoring that you can see in real time on the screen. Once you're done, okay, these maps came right out of John Deere Operations Center. Okay, in this particular operation, we applied 1.2 gallons of manure. We collected just over about 50,500 measurements collected. This is the total nitrogen in the bottom left. Okay, and I'll come back to that. The phosphorus is in the bottom right. And then here at the top actually is our flow rate, or gallons per acre applied up here in the top right. Going down here, I'll start with this, but if you notice on the total nitrogen and in the phosphorus map, we start applying over here, down here on the left side, and as we go, you can start to see the values start to decrease. And so then we come to the north side of the field and kept going. We moved across, okay, to this other side, and then ultimately we ended up on the other side of the road applying. But you can see as we applied some variation in both the nitrogen and the phosphorus. At least for me, and when we were doing this, the idea is this, at least I have it documented. And as I think about future applications, whether that's probably out 2 years from the point of this application, I might be thinking about, well, I need to start on the other side. If we're going to actually see, as I pump the pit down, things increase or decrease. Okay, in this case, it was decreasing. That red line I showed you earlier. I want to start on the other side of the field, trying to level out the application over time. So these maps, though, we could just debate on the accuracy of them. They do give you relative differences if things are changing, where that occurred, and you can think about that for future applications, future planning when you're thinking about nutrients out in these fields. So at least we have it documented and we know what happened out there. You can print these summary reports. Again, this is pretty standard out at John Deere Operations Center. This was done in 2022. Okay, it gives you quite a bit of data. I just blew up the data. Not only did I get a map over here on the right, but it gives you a lot of information, including the performance of the tractor as well in terms of fuel use and information of that related to the tractor. So you get those. That's just a print function, or John Deere Operation Centers allows you to download as a PDF if you need it for records or wanted to share with someone else as well. So pretty standard map and give me a full summary of the application out there in the field. So what have we learned? A couple slides here. We did learn through so far through that the P&N concentrations can change as we pump these pits. I will note that the pits that we were using were not agitated. Okay, these were unagitated pits at the time. So in that sense, that if things did change, the sensor was providing pretty valuable information like what I showed you in the prior slide. We knew where things were changing, where we kind of were higher and lower concentration in terms of applied nutrients in the fields that we applied to. We do still need some sensor calibration. I haven't highlighted that, but because of these NIR sensors, you need to calibrate specifically to the type of manures that you're getting into. Obviously, we can get into some very interesting things. I showed you some swine. We did some dairy. We did some dairy and beef combinations, but you need calibration curves to make that NIR sensor as accurate as possible. And I would argue that we probably still need to work on that a little bit in order to improve the performance that we saw out. And then as applied maps provided value and provided that verification of where things were applied and how much. Some other things that's happened are just just want to reiterate that in Europe it's being used and they're getting pretty good and accurate results out of it. Because primarily it's being certified over there. So there's a lot of time spent to make sure it's certified in order for farmers to meet the accuracy requirements in Europe through the DLG. Recently, Michigan State published some data that stated basically it did pretty well for hitting the N rates, okay, versus our traditional way of applying fixed rates out there. But having it basically was giving us much more accurate. And so the sensor applications were within 20 to 30 pounds of the N rate versus being off 40 to 95 pounds of being over applied in the project that they were doing. However, the Harvest Lab 3000 was not as accurate for the P and ammonia during those applications. Okay, so which was concerning. But for nitrogen, it was pretty close and it was an improvement over the traditional. So at the end, basically their take-home message was the sensor did a better job of matching crop in needs without over applying nitrogen, which is a value to using the sensor. I put this together real quick, Jocelyn, and I'll turn it back over to you. But just some of the highlights of research that I've been able to find. Obviously, that's DLG certification in Europe. So they're maintaining accuracy compared to certified labs, especially using nitrogen in Europe. Wisconsin said that they using the sensor, there was an opportunity to reduce 40 to 95 pounds of nitrogen per acre reduction. Okay, again, matching and not over applying. Obviously, we just talked about the Michigan State results, okay, and improving nitrogen delivery. And then with this, there's economic savings, and ultimately with the information in terms of the reports and the maps, there's some better improved documentation that can be used either for future planning or within require reporting back out to folks. So that's kind of a quick overview to date. Obviously, we're kind of limited on what we have access to as this technology here in the state, Ohio at least. We're kind of limited to using John Deere technology, but as we look forward, maybe some opportunities to see some others bring sensor technology, this type of technology, to Ohio farmers. So with that, Jocelyn, I'll turn it back over to you.
Thank you very much for that wonderful presentation. Um, let's see here. If anyone has any questions, please feel free to put them in the chat box if you didn't see the message come through. I did see one. Does Ohio State have any plans to continue research or start research on this type of technology? Anything exciting coming up?
I'm just getting to sorry, there's too many things open. So, see, Ambria, if I see that as a question is how are growers and researchers evaluating return value of the Harvest Lab? We'll say Harvest Lab 3000. And the second part of that question is, do we anticipate more applicator sensor adoption with fertilizers arising? So I would say a couple things, Ambria, to that. So how are we evaluating? Obviously, in our research, we're attempting to evaluate technology in two ways. We've done quite a bit of work on the ROI that's not related to this particular project, but in some of the other precision ags. But what value, dollars and cents, does some of that bring back? Um, and then trying to also think about how the technology could influence decisions and making more efficient use of nutrients out there. We're working on some projects related to that. That could be dollar and cents, or in a few cases, we've had use cases where we still got the same amount that we're applying. We're just applying it um, differently in different parts of the field. So we still got the total amount, which is the same. It does cost to have variable rates. So that's an additional cost, but we're just redistributing the application of those nutrients to better match crop or in some cases soil testing results that are done in like a management zone. So we are trying to do some of that. I think we need to your second point about these sensors, I think there's opportunities. We're working to try and improve the accuracy of this technology with groups like John Deere and others. We know that what we feed our livestock in a state greatly impacts what's in the manure resulting. We do, as I showed, know that the variability. I think the question is, though, does our ability to spend $30,000 to $45,000 to make that improvement, can we make that money back? And the answer to that is potentially yes, as to your point, fertilizers prices rise, but I think we've got to do a little bit more work on making the technology, I guess, more accurate and more applicable to our situation here in Ohio in terms of manures we're applying. I think if we could build that and build trust that what we're getting back, I think we'll start to see potentially maybe even some cost share come about on this technology, which really would help overcome the capital cost up front. But I think we'll also see, if that does happen, we'll probably see more use of this technology in the long run. My hope is it actually will reduce in price over time, as we see it used more and more in other applications, just like I mentioned on combines. So hopefully that answered your question.
Well, that's awesome. I had one that had came in just to myself, and that was you answered that as well. Um, let's see. Have you looked at any of the comparisons in the equipment as far as if there is any information on the ROI overseas compared, like things maybe we could look forward to seeing? Obviously we're limited on that technology here today, but maybe they have other cost comparisons. I know that gets a little bit tricky with everything, with inflation and everything, but is there anything on that you have seen?
As far as the NIR sensors, is that what
Mm-hmm.
we're talking about?
Mm-hmm.
Um, well, I just want to state in Europe, there are situations quite a bit different than what we have here in the US as far as compliance and regulatory end of things. And so the sensor kind of really Some of their RI is just the efficiency of having the records and having that in electronic format rather than having to make notations, in notes and things like that. So I think a lot of theirs has been efficiency, but it also is the requirement to have all this data available for the reporting. And so it's meeting a real need over there in terms of what farmers have to report or provide, on an annual basis to agencies about manure application, manure management type things. And so the biggest ROI that I've learned from specifically in Germany, talking to the growers that use it, is the efficiency from just the record keeping and the reporting that they can actually build into, we'll just say a PDF. I've got that and I can put that on my report rather than having to type it in or write it down and then scan it in some cases. So that's been my learning from them is just the main efficiency is the reporting of it. So obviously they have the DoD certifies the sensors, so that's given them a confidence level that and the agency's level to accept that data that's coming off of those sensors as well because they're testing it and certifying it annually. So the farmers don't have to worry so much about the accuracy of that because in that case in Germany it's being tested. Whereas here we're trying to get, what calibration curve should I put in for the manure that I have at my farm, okay? Or if I'm a custom applicator, what is the manure source and is there an appropriate calibration? We're kind of guessing at that a little bit today, in some cases.
I don't see any other questions coming in. But with that, I am going to launch the poll. If you need CLM credits, you do have to fill out this poll. So I need you to answer yes, and obviously follow part 2 as entering your name. That way we can make sure you get the credits that you need. So I will leave this up here for a little bit, maybe a couple minutes here, and then we will move on to getting you those CCA credits. I would just like to thank you once again, John, for being on and for explaining all of this wonderful research and kind of the up and coming things we can hopefully look forward to maybe seeing implemented in this area. And if anyone does have any questions for him that you didn't put in the chat box, you can email them to me, email them to the team, and obviously we can get those answered for you there. So with that,
Thanks, Jocelyn.
yeah, unless you need credits, you all are free to go.